So last time we have talked about how to find out p-value. So remember the slide that we have seen? If p-value is small, that means the result is statistically significant. If the p-value is large, that means the result is not statistically significant. So the statistical significance is quantified with the p-value. And we've also talked about the general p-value definition as this, and how you are going to find out the p-value when you are seeing a practical question. So this is the practical p-value definition. Okay, so this is the PowerPoint that I shared on Moodle as well. So you are able to see these PowerPoints as well. So now let's go back to our note. We have talked about so many regarding the hypothesis test. Let's really take a look at a complete example to see how we are going to do this. Now, if you haven't read this example yet, I would suggest you to pause the video for a while and read the question and think about how you will do it for a little bit time before you continue. And since I'm recording it, I'm just going to continue to talk about how we are going to solve this example. Okay, so remember, we have talked about 4 steps when we try to do hypothesis test, right? So the first step is to establish H null and HA. So our H null is mu equals to 60. Remember, we said our H null is always going to be the one with the equal sign. We are trying to see whether the true mean is really 60 or less than 60. So this equals to 60 goes to H null. The alternative hypothesis is the research question. What we try to find out. What is our new theory that we proposed? I suspect that the mean caffeine content in a cup of half coffee is really less than 60 milligram. So that would be mu less than 60. So our mu here represents the true mean caffeine content for this brand. So this is the first step. The second step, check the conditions and calculate test statistic. So let's check the conditions first. The first condition, it needs to be a random sample. And it has told you that this is a random sample. So we have been told it's a random sample. And second, condition is the population needs to be normal, right? But we also mentioned that this assumption is not that strict. You could violate it a little bit because the test is robust. So even though you violate the assumption a little bit, you are still going to be okay. So we don't know if it's normal or not, but it's reasonable to believe that it's going to be at least symmetric. So we could go ahead to continue our procedure. So let's calculate the test statistic. The formula is T statistic equals to y bar minus mu now divided by S over square root of n. Y bar is your sample mean, which your sample has a sample mean of 58.5, and now mean now is this 60 divided by sample standard deviation 2.5 over square root of 10. I'm sorry for the cough. I try to not cough, but it just I can't help it. So if the experience is not very well, I'm really sorry about that. I hope to provide the best recording I can. So this value is negative 1.898. So I am not sighing because I don't feel comfortable with this. It's just I try not to cough. So this is the test statistic is negative 1.898. So that's the second step. The third step is we identify the null distribution find p-value and make decision about H null. So the null distribution, this is short for distribution, is a T distribution with degrees of freedom equals to, remember the T distribution has a degrees of freedom equals to n minus 1. So our n sample size, is 10. So this is 9 here. The p-value, we have talked about how to find p-value in our last video, right? So this has a alternative hypothesis with a less than sign. So the p-value would be the probability of the test statistic less or equal to negative 1.898 under H null. So if we draw it, this is our null distribution. It's a T distribution with degrees of freedom equals to 9. center is 0. We have a test statistic equals negative 1.898. So the p-value is the area under the curve to the left of your test statistic. If you use the table, so from the table, this p-value is in between 0.025 and 0.05. If you use stat crunch, this area is 0.045. So the p-value is 0.045. Now this is our p-value. The next step is to make decision. How do we make decision about our null hypothesis? The rule of thumb is if p-value less or equal to alpha, we reject H null, right? Now here, our p-value is 0.045. Our alpha is given here 0.10. So our p-value is less than alpha. So we reject H null. The last step is to make conclusion in the context of the question. So make conclusion in the context of HA. So we will say there is evidence that the true average amount of caffeine in this brand is less than 60 milligram. So that's the end of this question. It follows the 4 steps that we have talked about. So the first step is establish. No, that's not what I want to highlight. Okay, seems like I can't do it. So the first step is to establish H null and HA. Second step, check conditions and calculate test statistic. Third step, identify null distribution, find p-value, and make decision about H null. The last step, make conclusion in the context of HA. Now let's go back to the discussion board question that I assigned you guys at the end of last video. Okay, here comes the exciting time. Who is correct? So the first one, the probability of observing, we are talking about the interpretation of the p-value we just calculated. The probability of observing a test statistic less than or equal to negative 1.898 is 0.045, assuming the true average amount of caffeine in a cup of a half cup is 60 milligram. That one is correct. That is what p-value is, right? The probability of having the test statistic less or equal to this is 0.045 under H now. The second one, a test statistic of negative 1.898 or smaller would be observed in 4.5% of repeated samples of size 10, assuming the true average amount is less than 60 milligrams. This one is also correct. This is actually the same as the first one. It's just instead of saying the probability, it explains how you got the probability. That's by repeated sample of sample size 10. The third one is the one that is not right. So this one is wrong. What's wrong with this? It says there is 4.5% chance that the true average amount of caffeine in the point is 60 milligrams. What is actually implying in a sentence like this? It implies that the p-value is the probability H now is true, right? The true average amount of caffeine is 60 milligrams. This is H now, right? And it is saying that the probability that H now is true is 4.5%. And that is not correct. That is not what p-value is. P-value is the probability that you are going to observe the test statistic that you calculated are more extreme under the null distribution. So what should be true is instead the p-value is the probability we would get data we did if H now were true. So if H now is actually true, what is the probability that we would get the sample data that we got? If this value is really small, we will reject H now, which means H now is probably not true. That's the reason behind it. So that is the probability we would get the data if H now were true. H now here is just providing the frame of reference. The now distribution that we evaluate the sample data against. We are trying to see if our sample data is, quite reasonable to appear in this null distribution when H null is true, or it is kind of like surprising under the null distribution when H null is true. Thus, we could determine whether we should reject or not reject H null. The last one is also correct. It is again another way of saying 1 and 2. The probability that the null distribution less or equal to 1.898 is 4.5%. Okay, that's the end of this video.